Okay, so moving on to part B. As I said before, we can use differentiation because we're no longer able to just look at a constant gradient from a curve, like constant acceleration, because it's variable. Differentiation, one of the uses of differentiation is finding a gradient. Okay, this can be used to find acceleration, but it can also be used to find velocity as well. So velocity, remember, is how displacement changes over time. So if you differentiate displacement with respect to time, you'll get velocity. You'll get an equation in velocity when you used to have one in displacement. And if you differentiate velocity with respect to time, you'll get acceleration. Or another way to think of that, if you like, is if you differentiate displacement twice. So this is how I think of it as well, actually. So I think of displacement at the top, then velocity, then acceleration. And to move down between them, you differentiate. And as we'll see in the next section, to move up, you integrate. You have to do this here to move between them because things are not constant. They're changing. Okay, they're changing. You've got like curved acceleration and so on. So the Subat equations don't work. You're going to have to differentiate and integrate instead. A couple of examples. So a particle is moving on the x-axis at time t second. The displacement, occasionally displacement is called x, especially in mechanics, from the origin. So it's given by this. Okay, so there's some particle. When t equals 0, it'll be at 14, won't it? So we start off with the particle over here, and it's going to do something. Okay, it's going to do something. It's not clear yet what it is. So what's the velocity when t equals 3? Well, I don't know. I don't know because that equation there is not for velocity. It's for displacement. So I'm going to have to differentiate down my equation. Then I will be ready to use this one. So I need to differentiate t to the 4 minus 32t plus 14. I have to differentiate that thing. It's 40 squared minus 32. And then if I want velocity at that time, you put that time into the velocity equation, which is this, 76 meters per second. That should be a 1, that shouldn't be a 2. What's the value of t? So t equals what? When p is at rest. What does at rest mean? At rest means v equals 0. So we use the same one again. So v equals 4t cubed minus 32. When it's at rest, the v is 0. So we're going to solve that one there. Okay. T is 2 is what we get. Finally, what about the acceleration? Well, I don't have an acceleration equation, but I do have a velocity equation. So now we're going to differentiate down from velocity. We're going to differentiate and we'll get our acceleration. So 4t cubed is going to become 12t squared. And the 32 will disappear. So that will be my acceleration. We put the 1.5 in and we get our answer here. So try and get sort of the hierarchy of displacement, velocity, acceleration right, differentiate down, integrate up. Test your understanding with the questions there on the board by quickly pausing the video. I'm going to assume that you've done that. So differentiate for velocity, plug in the value. At rest means v equals 0, so put v equals 0 into the v equals equation, the velocity equation. You can ignore the minus 3 because that's not a possible answer. Acceleration, you have to differentiate again and then put in t equals 5. And that takes you to 11b.